We don't train you for a piloting exam. We teach you how to fly, as is stated on our website. It's not our motto. Well, it's one of our mottos, certainly. Right, so now we start a maths webinar. I'm sorry, I said physics. I made a mistake. It's obviously maths. It's trigonometry. And you should be seeing my screen. Rachel, if you would be so kind to answer some of the questions in the chat. I think I've, yeah. Yes, assignments can be submitted electronically by all means. All right, that's the last question about COMPOS. So yes, trigonometry. Exciting because we do trigonometry a little bit differently, a little bit more thoroughly than you are used to in school. And the so the major difference will come with problem 4, but let's quickly go through. So problem 1, monotonic functions and inverse functions. So monotonic functions, you might know them. They are also known as one-to-one functions. One-to-one functions. One-to-one continuous functions, of course. So for example, a function like this is a monotonic. And this function is not monotonic. So what is a monotonic function? A monotonic function is a one-to-one function where each value of x corresponds to exactly one value of y. But also there's a different definition. A continuous monotonic function has it's the derivative of that function is either always positive or always negative. That's another way of looking at it. If the derivative is always positive, it's a growing function. It's an increasing function. It's an uphill function. The gradient is always positive. Whereas in a non-monotonic function, the gradient can be positive or negative. It can change. A monotonic function has no turning points. Right. So, and then the only one-to-one functions have inverses. So if we're talking about continuous functions, and we usually talk about continuous functions, then only monotonic functions have an inverse. Let's put it this way. A monotonic function always has an inverse, right? A monotonic function has an inverse. So when we say find the inverse of sine, you probably know that the inverse of sine is sine minus 1x. Inverse sine minus 1x. But sine x is not a monotonic function. What's the deal with that? Does anyone know how to? Does anyone know what I'm talking about? Sin, yes, this is an odd function by all means. Yes, Paris, thank you. You only take the principal angle values. You only take a short piece because the sine function is periodic. So it looks like this. So by all means, it is not a monotonic function. But if you take only a small piece of it, if you only take this piece of the sine function, it is monotonic. So sine x is not monotonic. But sine x, where x belongs to the interval from minus pi to pi, know what I'm talking about, minus pi over 2 to pi over 2, because this is minus pi over 2, this to pi over 2, is monotonic. So it has an inverse. The inverse, so if f of x is this, the inverse function is arc sine x, also known as sin minus 1x. Inverse sine, yes, inverse sine has to be monotonic. And if you draw the inverse sine function, you will see that by all means it is. It is only defined from -1 to 1, and it has a range from minus pi over 2 to pi over 2. And then you draw it, and it looks like this. Okay. So if we look at this function, for the red function, the domain is minus pi over 2 to pi over 2. And the range is from -1 to 1, because this is -1 to 1. And here, the domain is -1 to 1, and the range is from minus pi over 2 to pi over 2. So yeah, that is it's always like that. The domain of the function is the same as the range of the inverse, and the range of the function is always the same as the domain of the inverse. So this is the function, and this is the inverse function. All right. So hope that makes sense. Can you explain monotonic? I don't really understand. A monotonic function is a function that always increases or decreases. So like this is a monotonic function. This is not. This is a monotonic function. Right? We can also have monotonic function that goes like this. So for a monotonic function, the definition monotonic is or the increasing or decreasing. If it's an increasing function, then if x2 is greater than x1, then f of x2 is greater than f of x1, greater or equal. Monotonic decreasing, if x2 is greater than x1, then f of x2 is less than or equal to f of x1. So simply, if you take 2 points, x1 and x2, this one is higher. So the function is going up. And a decreasing, if you take x1 and x2, the function is going down. So f of x2 is less than or equal to f of x1. And here f of x2 is greater or equal than f of x1. This is what a monotonic function is. It's an increasing or decreasing. The consequence of a function being monotonic is that the derivative of the function is greater or equal to 0. And for a decreasing function, the gradient, the derivative, is less than or equal to 0. Does that make more sense? Is y equals 0 monotonic? Well, according to this definition, yes. But then we just need to make a better definition. We have, I see. Yes. Okay, let's introduce the term strictly monotonic, and that means that it's greater like this. So I fixed the problem. Strictly monotonic functions always have an inverse. Thank you for pointing me into that direction. Strictly monotonic functions have an inverse. Domain range we'll go through in more detail in further assignments. We have an assignment on functions, but they are also covered in the assignment itself. So please have a look as well. So is x cubed not strictly monotonic? You're making my life difficult. Well, no, apparently not. So it has, yeah, like this. So yes, this is a consequence. So this is a consequence of this, but this does not mean that. Okay, so from left to right it works, from right to left it doesn't. But decreasing monotonic is still x2, yes. If x2 is greater than x1, then f of x2 is less than f of x1. So basically, if the point is to the right, it's lower, or if the point is to the right, it's higher. But that's not the thing I want you to focus on. Okay, we will do a whole assignment on functions, so don't worry. The point I was trying to make is that monotonic functions are one-to-one functions, and one-to-one functions have an inverse. So in order for a function to have an inverse, you have to limit the domain. The domain is the possible values of x. So domain is all possible values of x, and the range is the all possible values of y. Could monotonic also be defined as each output going to have one corresponding input, which would still allow for the gradient of 0 at single points? Well, Joel, if you add to that they have to be continuous, then yes. Okay. Why do non-monotonic functions do not have an inverse? So this is the whiteboard. Because the inverse would not be a one-to-one, one-to-many function. Yes, thank you. That is pretty much the answer. Let's cover this. Right. For a function, is one-to-one or many-to-one. It cannot be be one-to-many. Many. What does that mean? Well, if you have a graph and you have a function like this, you have two different values of x correspond to the same value of y. That is okay. This is called a many-to-one. Many-to-one. However, if you have this and a function is like this, for the same value of x, you have three different values of y. This is one-to-many. One-to-many. A one-to-many mapping. It's a one-to-one, many-to-one mapping. One-to-many mapping. So this is not a function. With a function, you always have to know, if you know x, you always know y. This is how functions work. If you know what you're putting in, you know what you're getting out. If you're putting in x and you don't know what you're getting out, that's not a function. Sorry. Right, sorry. Apologies. Yes. Right. Can I please ask you to use the chat for maths questions? Right. Okay. So with a function, you always know the output. If you know the input, you know the output. If you don't know the output, that's not a function. So the inverse function is a reflection of the function. Is a reflection in the line y equals x. I really don't want to go very deep into this because that's not the point what I was trying to make. But basically, if the function is like this, the inverse of this function is going to be, so if the function is many-to-one, the inverse is one-to-many, and therefore it cannot have an inverse. You can oh, I wonder, we should have this in the assignment. So here's where you find assignment 2, in case you didn't know. So And we dig right into. Anyways, we have a separate assignment on functions. Okay, so don't worry if you don't fully understand. I have to move on. I have to move on from the functions. Why is arcsine given as an alternative name? Arcsine and inverse sine. Arcsine is the original name, and then somebody decided to give it a simpler form, sine minus 1. But yeah, they're not different. It's the same thing. So we need to find arcsine of sine 300. And we remember that arcsine has a domain of negative 1 to 1. So and all right, sine 300 yeah, definitely less misleading because sine minus 1 can mean like sine squared. Sine minus 1 can mean sine 1 over sine. So arcsine of sine 300. So you need to find sine 300 first. And sine 300, you need to use the trigonometric circle. Trigonometric circle. So you have 300. So where is 300? So this is 0 degrees. This is 90 degrees, 180, 270 degrees. So 300 is somewhere here. 300 degrees. So it's 60 degrees short of 360. So 300 is here. The coordinates of this point, this is how the trigonometric circle works. The coordinates of these points are the cosine and the sine. Well, how do you know where they are? Well, we know that this is 60 degrees. So if we draw a line like this, this is going to be 60 degrees. And we know cosine 60, we know that the coordinate of this point is cosine 60, sine 60. We know cosine 60 and we know sine 60. We know that this is 1/2. We know that sine 60 is square root of 3 over 2. So this point on the trigonometric circle has coordinates 1/2 and square root of 3 over 2. Now this point is symmetrical to this point. Therefore, the coordinates of this point is 1/2, comma, minus square root of 3 over 2. How well do you understand this? On a scale of 0 to 10, please. Don't be shy. Okay, so that's good. Oh, nice. They're the same because they are symmetrical, because this is 60 degrees and 300 is 60 degrees away from 360. So they have the same x coordinate, but opposite y coordinates. Unit circle, yes. Unit circle and trigonometric circle is the same thing. So that means that cosine of 300 is 1/2. Sine of 300 is minus square root of 3 over 2. So arcsine of sine 300. This is the same as arcsine minus square root of 3 over 2. So which angle, and remember, arcsine has a range between minus 90 and 90. So you can only have a value between minus 90 and 90 of the angle that is has the same arcsine. And this angle is, of course, minus 60 degrees. So arc sine of sine 300 is minus 60. Okay, so if you draw the graph, if you sketch the graph of arc sine, sorry, that's not pi over 2, because we're doing degrees. So this is 90 degrees, and this is minus 90 degrees, and this is minus 1, and this is 1. So this is like an this is like a sine graph, but we've twisted it. And square root of minus square root of 3 over 2, that's somewhere here. Minus square root of 3 over 2, that's somewhere here. And it turns out that this is minus 60 degrees. Yes, thank you. That's the correct answer. The conversion. Right. So that's that. Problem 3. Sketch the graph y equals arctan of tan x, indicating the domain and the range. Well, what do we know about the tan function? Tan x. Well, we know that x cannot be equal to 90 degrees because tan 90 degrees does not exist. It also cannot be equal to 270 degrees. It also cannot be equal to 450 degrees. The list goes on. I wonder if there's a way we can put this in a single line. Does anyone know how to? Oh yes, thank you. It's a sequence. Remember in year 7 or 8, you learned how to do sequences in terms of n, yes. So what is the formula for the nth term of this sequence? And you would know that it is minus 90 plus 180n. But n can be anything, so we don't really need the minus. We don't really need the minus. So, but yeah, x is not equal to 90 plus 180n, where n is any whole number. In radians, the same thing would be written as this. X is not equal to pi over 2 plus pi n, where n is a whole number, is an integer. Yeah, sorry, whole numbers and integers apparently are different. Well, they're not in my book, honestly. That's not how I learned stuff, but integers, yes. Yeah, so that's the domain of this function. Okay. Well, you know that arctan x has a domain of is an infinite domain. So there are no limitations. Okay. We know, in general, we know that f minus 1 of f of x is x. This is as in general. In general, this is how an inverse function is defined. We know. And we also know that arctan is the inverse of tan. So certainly, yeah, Yasin, they are the same. Arctan and inverse tan are the same. Some mathematicians make a difference, but you should have been taught this in GCSE, because this is from GCSE stuff. GCSE. There's nothing new here. The inverse function, it's a f of f minus 1 of x is x. Like, for example, the square root of x squared is x. Well, within limitations. Yeah, well, I mean, yeah, it depends. You've done a composite function, right? So you've done a function of f of g of x, right? So you've done composite functions. So this should be, okay, some specs might not have it, but yeah, as a general, just look it up. Inverse, inverse functions. The inverse function undoes whatever the function did, right? The logic is here. So if you take the function is a magic box, I like to say the function is a magic box. And if you put in a number x, you get out y. Now the inverse function, if you put in y, you get x. It does the opposite thing. So if you put a function into the inverse function, you get what you started with, you get x. And the arctan and tan are inverses. The arctan is the inverse of tan. And therefore, for within the range from minus 90 to 90, that's where from minus 90 to 90, minus 90 to 90, the function behaves like this. Now we know that x cannot be equal to 90, so this is a point. This is a we're not including this point, and this is 90. 90 degrees. Now, arctan is a periodic function. Tan x is a periodic function. What does it mean? That tan of x plus 180 degrees is equal to tan x. Yes, it repeats with a period of 180. But that also means with period 180. So tan x repeats itself with a period of 180. It's very, very easy to confirm. So very easy to confirm. If you draw y equals 10x, you see, it repeats itself every 180 degrees. This is how the graph of 10x looks like. That means that arctan of 10x, because if 10x repeats, then the whole thing repeats as well, is a periodic with period 180 degrees. It's like sine x, I'm just explaining the logic. Sine x is periodic. Yeah, I don't think there's anyone here who's going to deny that. It is a periodic function. It has a period of periodic with period 360 degrees. Sine squared x, well, sine x squared will also be periodic. Even though x squared is not periodic, we definitely know that sine x squared is periodic. I've posted the link above. Somebody copy that link, please. Thank you. Yeah, so let's have a look. If you take sine y equals sine x, it's periodic, obviously periodic. Then sine x squared is also going to be periodic. Interestingly enough, it's actually a transformation of sine x. Right? You would assume that it would go something like this, something like when I always imagine it like this for some reason. I always imagine sine squared x like this, but it's not. After you consider it, it doesn't look like this. Okay, so it's a periodic function. And so basically all we need is to repeat this part periodically. So if we shift by 180, it's going to be like this. So this is 270 degrees. And this is minus 90, so it's going to be like this. It's going to be like this. And on the left, it's going to be like this. So the function is going to be straight lines. Straight lines. The edges are not included. That's why we have circles. The edges are not included. Right. Minus 90, of course. Minus 90. Thank you. X and Y. And let's have a look. I've drawn this function, and indeed it looks like this. Now this is in radians, of course. That's why it's not 90. It's in radians, but you get the idea. It's a straight line repeating itself. The edge is given as 1.57, but there's an undefined point at the end. All right, so why isn't the domain restricted? Well, because it is restricted. It's in a way that it's not equal to 90. It is restricted, but tan x, look, tan x, x can be anything, and tan x is, well, it's going to be fixed. Because if you take a composition of the function and an inverse, it's always going to be x. So for example, f of x is x squared, and f minus 1 of x is square root of x. These are inverse functions. And if you take the composition minus 1, which is the square root of x squared, it's going to be x. And it works with all functions. For example, a logarithmic function. Well, you haven't done logarithmic functions yet, so let's make something simple. Okay, f of x is 3x plus 1. The inverse function is going to be x minus 1 divided by 3. Now, if you take a composition of f of x, so it's going to be 3x plus 1 minus 1 divided by 3, and this simplifies to x. If you take, yeah, y equals x. Yes, so it is y equals x. Y equals that. So this is the line y equals x. Y equals f minus 1 of x, which is x. So y equals x. And then you just copy, you just make copies. It's quite amusing. So just I advise you to explore it. You can always do a spreadsheet. Yeah, so I like doing spreadsheets. So if you take a spreadsheet, so you can do x, tan x, and then arctan tan x, and then you start with, I don't know, 0, 5, 10 equals 10 x. Okay. And oh, that's in radians. So it doesn't like, okay, well, then 0.1, 0.2, and then equals arctan. Doesn't like arctan. Inverse tan. Tan. Atan, yes. Atan of this. And then you just autofill and just drag it. Then just analyze. And look, it repeats. You can see that it goes from 0 to 1.5. And then it goes from 0 to 1.5 again. 1.5 again. Oh, it goes up to 1.6, but you can definitely see that something's going on. Yeah, and you can draw a graph, of course, and it's gonna be, yes. So yeah, what time? Oh, spent so much time on this. I'll plow quickly through. Look, I have done at least 3 webinars on this topic. Do you all know where to find the previous webinars that I've done? You go to YouTube, to our channel, And here we have playlists, and you have Year 12 webinars. If you click on Year 12 webinars, and you have vectors and physics, quadratic function, trigonometric functions, and motion and trigonometry. So you need a webinar 07 and 09. So I've done 2 webinars, and there's another one in the others. So I've done 3 webinars on this topic. So please have a look, because there's nowhere near enough time to go through everything. And these can be accessed on our website, of course. If you go to our website, if you get involved webinars about COMPOS webinars, you can see all the Year 12 webinars and the links to the whiteboard. Okay. And you can also have a sneak peek of what we do in Year 13, if you wish. Right. So the main difference in your assignment is when you solve an equation, a trigonometric equation, you don't just give the principal values. You don't give a standard 0 to 360. You give all the values. So for example, this one, this equation, and you can take this. So you have this, you draw a circle, and sine is equal to -1/2. Sine is equal to -1/2, and that's going to be here and here, because obviously this is -1, this is 1, this is 0. This is a circle with radius 1, so this is -1/2. So these angles give you -1/2. So these are, we already know that sine 30 is 1/2, so this is 30 degrees away, 30 degrees away. So this is, if this is 180, this is 180 plus 30, and this is 360, 360 minus 30. Well, yes, but also, I mean, this is not 360. This could be 360 plus or 360n, because n can be anything in 360n. I've done this problem probably at least 2 more times in the previous webinar. So do have a look if you are unsure, because I have to finish in a few minutes. And this is not 180. This is 180 plus 360n. So 360n plus 180 plus 30. So the answer actually is 210 plus 360n, or -30 plus 360n. Now, this looks a bit ugly. So basically, we say x is either 210 plus 360n, or x is -30 plus 360n. So let's have a look at the sequence. The sequence here, 210, then 210 plus 360. Well, you start with -1. Okay, no, okay, I don't have time for that. So 210, 210 plus 360 is 570. Here it's -30, so it's 330. And start with 0, so it's -30, 330. The next one is going to be -30 plus 720, 690. Yeah. Now, there is a cleverer way of writing the same thing in a single line. So it looks like this. X is equal to -1 to the power of n multiplied by n plus 1, sorry, n plus 1 multiplied by 30 degrees plus 180 multiplied by n. Yeah. I would like you to analyze this. So start with n equals 1. This is going to be 1. So n equals 0. Start with n equals 0. This is going to be 0 plus 1, so minus 1 to the power 1. So -1 times 30 plus 0 is going to be -30. Then you go n equals 1. N equals 1, and that gives you 210. N equals 2, and it gives you 330. N equals 3 gives you 570. N equals 4 gives you 690. So all of these values that you have here, you can get from one single formula. And I think this is a very nice formula to use. You don't have to use it, but that's yeah. If we also do the okay. So this is all I have time for, unfortunately. So yes, do watch the other webinars if you are still uncertain about trigonometry. And I'll answer your questions. I have some questions here. I'll answer them. And I wish you all the best, and see you next week. We also do the year 13 protocol. Would it be possible to send out the assignments ahead of schedule? I have to think about that. I think we can give you last year's assignments that you can work through. If you do the year 13 assignments, if you do, so you can join year 13 follow along. Yes, that means you can do the year 13 assignments and submit them at the end of the year. And if you submit the whole set, I will have them marked. And you can potentially complete year 13 and 12 in 1 year if you wish, if that is your aim. Yeah, so by all means, if you want to complete the year 13 assignments and submit them at the end of the year, so you send me an email saying, I have finished all the year 13 but be very specific. I am in year 12, but I also completed the year 13 assignments. Or I'm in the follow along group, I have completed the year 13. We will acknowledge that. We will get that marked, and you'll get recognition for that. I mean, you will receive a letter of completion. Archie, yes, you can use -1 times n to the n times -30. That is correct. Okay. Oh, that's the largest number of thank yous I've ever received, I think. Yeah, that's good. Yes, Paris, we are incredibly busy at the moment. So if you send us an email asking for the assignments right now, we might lose your email. So please, in a few weeks, just repeat that question, and we'll see what we can do. All right. See you then. See you next week. Enjoy.